Hello friends, this is Dr. Amarjeet Kaur, Professor of Accounting and Business Communication at the Department of Management, Gurugram University, Gurugram. It's my privilege that I am here with you today to talk about time value of money, and we are going to talk about only compounding in this session. So friends, compounding is something which we all are familiar about. We all know compounding being used in banks, especially for our basic savings or for FDs, etc., etc. So this is something not very unfamiliar. It is very familiar to all of us, and businesses also use compounding, and compounding means that we earn interest on the interest earned in the previous year, right. So in the fourth year, my interest would be based on the previous 3 years of interest. In the fifth year, my interest earning would be on the first 4 years, whatever I earned as interest, I will be earning interest on those 4 years interest. That's what compounding is. So there are 5 different situations in compounding: annual compounding of single sum, more than once compounding of single sum, compounding of uneven cash flows, compounding of annuity, and compounding of perpetuity. So there are 5 different situations. We will be discussing about these 5 situations in detail. So first is annual compounding of single sum, means I am depositing only one sum, be it 1 lakh or 10 lakh or 10 crores, right, irrespective of the sum I am depositing, but I am depositing only one. So from 100 rupees to any amount, or from 10 rupees to any amount. So my deposit is once, and the time of compounding, how many times in a year the compounding is done, it's once in year. So that's why we call it as annual compounding of single sum. So let's learn that how this situation falls in, or how it works. So let's take with the help of some example or some small caselet. So there was a person A, he has deposited 10,000 at the end of each year for the next 3 years. If the bank pays 8% interest annually, how much would A have 3 years from today? So here what we are doing, we are taking future value, the equation of compounding. Future value is equal to present value, right, of annuity, and multiplied by future value interest factor of annuity. So here what is happening? So we are depositing single sum, but the sum is in the form of annuity. Okay. So but let's take a simple another example. If you are depositing 108 rupees in the second year, previous year you have deposited 100 years, it becomes 108 in the second year. So how much would you have after 2 years? So the equation is very simple, that future value would be equal to P into 1 plus R raised to power n. That is what is the mathematics, simple mathematics. So it means 100 rupees, the is here P, the principal is 100 rupees, into 1 plus R, R would be 0.08 raised to power n, n would be 2 years. So that's how you will get future value. Okay. So basically understand the fact that what is happening here, 100 rupees is deposited only once, right, and n is whatever the n is given, and here was 2 years in this example, and rate of interest is 8. So any rate of interest could be there, the R would be replaced by that rate, it would be 0.08, 0.07, 0.05, 0.09, whatever the rate is available. Okay, and P here is 100. So if you solve this equation, you will get the compound value of the sum 100 rupees, which was the principal money invested at the rate of 8% for 2 years, right. I hope you could get that. So we can take few more examples to understand this, right. So this was the first situation, that annual compounding of single sum. But what will happen if we are compounding more than once, but the sum is once? So single payment means only one payment is been made, let's say 100 rupees, 1000 rupees, 1 lakh, but the compounding is done for more than once. So, here important is that annual, it could be annual, semi-annual compounding, which means twice a year, quarterly compounding means 4 times a year, monthly compounding means 12 times a year, weekly compounding means 52 times a year, daily compounding means 365 times a year. You know, there are many investments in, especially in stock market, where compounding could be done on daily basis, right. So, we have to see that how many times of compounding is done. Some is once, investment is only once. So, the formula which you have just noticed is actually we are calculating future value for given n is equal to the present value into 1 plus I divided by m raised to power m and n. Here what it is, m is what? The m is number of periods in 1 year. That is what I was saying. If I am compounding twice, the m becomes 2. If I am compounding quarterly, m becomes 4. If I am compounding monthly, m becomes 12, right. If I am compounding weekly, this m becomes 52, right. So, I means rate of interest or R, anything can be used, I divided by m. So, if my I is 8, you know, in the previous example our I was 8%. So, if my I is 8 and m is 2, I am compounding only twice a year, means I am compounding biannually, semi-annually. So, my I would be 8% would be divided by 2, right. So, it means practically my I becomes how much? It becomes 4. Same way, likewise, if my I is 8 and the m is number of times of compounding in a year, if it was quarterly, so it means I will divide I, which is 8% in this example, by how much? Did you get it? We will divide it by 4. So, my effective rate of interest would become 2%. So, I divided by m. So, and then if you, so the n was, let us say if n was 2. If n is 2 and I am compounding 4 times a year, which means quarterly, so my n would be multiplied by m. So, m is number of time of compounding. So, number of time in compounding in quarterly situation is 4, right. So, n is 2 years, but I am compounding 4 times a year, it means n 2 multiplied by 4 quarters of a year, it becomes 8 effectively. So, my n will become 8 effectively. So, m into n and I divided by m. So, the formula which was previously there in the single sum compounded annually, it was just 1 plus I raised to power n, right. But here we have changed the formula by dividing I, that is rate of interest, with number of times of compounding, that is m, and then n, which is that was raised to power n, is multiplied by m. So, this whole 1 plus I raised to power n is actually nothing, we call it as future value interest factor, F, or compound value interest factor. And when I say future value interest factor or compound value interest factor, means I am talking about compounding tables. So, we can get either one way is to solve this equation, which is very much with the help of calculator, with the help of financial calculator, we can solve this 1 plus I divided by m raised to power m and n, very fine. But another way to solve this same equation is that if we rewrite the same equation, future value for given n is equal to present value multiplied by my future value interest factor. Where does it comes from? It comes from that future value table for the given I and given n. And since we are compounding more than once, my given I is divided by m and my given n is multiplied by m, and that is where I have to look in the table. Okay. So, we will take some example. The semi-annual quarterly compounding means there are 2 or 4 compounding periods within the year. Interest is actually paid after every 6 months or half yearly in case of semi-annually. So, we will take some example and we will understand it in more details. So, here are two examples in front of you. If rupees 1000 are semi-annually compounded at an interest of 6% annually, how much would I have after 2 years from now? So, how many times we are compounding? Semi-annually means twice a year. And what is the rate of interest? Rate of interest is 6. So, my I6 is divided by how much? 2. So, my effective I becomes 3, right? 6 divided by 2. In the first example, I am talking about the first example only. So, my I becomes effectively 3. So, 1 plus 0.03. If you look at the a solution, it is given in front of you. So, 1 plus I is not 6. I am not using 6 because 6 is my given I is divided by m, and m is how much? Number of times of compounding is 2 here. So, divided by 2, it becomes 3%. And how many years we have? N is 2 years in the example, but n is multiplied by m and m is 2, right. So, 2 value of m is 2, value of n is 2. So, m into n becomes 4. So, it means I will look at the table for, if I have to use the factor, I will look in the table, I will look for percentage rate of interest column for 3% and the row I will look for N4. And if you solve it otherwise, you will get the answer 1125 rupees 51 paisa, which is given there. So, you can solve it two ways, by solving this equation I divided by m and n multiplied by m, or else use the factor from the table, your answer would be same. This was more than once compounding of single sum. Second example, we can take another example. If same 1000 quarter was compounded quarterly and rate was 6 only. Now what will happen? Just think, the 6% is going to be divided by what? By 4. My m is 4 now. I have consciously put both the example in the same slide so that you could compare and learn it better. So, here how much I am writing the rate of interest? 0.015, like half of 3 even, right. So, 0.015 means 1.5%. So, 1/4 of 6 is 1.5% of interest. And how much is my n? N is 2. N is multiplied by m. Here m becomes 4 because of the quarterly thing. So, I know I will go in the table, I will look for N8 and I 1.5, or otherwise I can solve this equation as it is with the help of calculator, and the answer would be 1126.49. Now, very important observation from the same slide. Do you see some magic happening here? Some magic is happening here. And what is the magic? Same 1000 rupees, let us say this example was for two different people. So, I have deposited 1000 rupees in X bank at the rate of 6%, where biannual compounding or semi-annual compounding was done. How much did I get after 2 years? I get 1125 rupees 51 paisa. In the second situation, you have deposited 1000 rupees, you are wiser than me, you deposited same 1000 rupees but with a bank which was compounding quarterly. How much did you get after 2 years? 1126.49. So, you have earned more than me, simply the same amount, same rate of interest, simply one difference, the time of compounding. So, that is something to be learned in personal life, in business, that how many times of you must have heard compound, and people may think it is very simple thing, it is, but the application is important and interesting. So, this example would certainly have helped you to understand the importance of times of compounding in a year, right. Now, we will move to the third situation where we are talking about compounding of uneven cash flows. In this case, the cash flows is happening in the form of uneven amount, means a series of payments, but they are compounded annually. So, That's the situation we are assuming. So, what would be the formula here? I am taking, since it is becoming complex, I am taking straightway, the future value of for given n would be summation of n, sigma n, the major bracket starts, the present value for given t into compound value interest factor. It could be future value interest factor, f or v, if could be used instead of CVIF, right, for given t, for given time period, bracket closes. So, here we are actually doing nothing, we are compounding individual sum every year and then we are making a summation, right. That is why sigma n, because my annual investment is different. Sometime I have invested 1000 rupees, another time I have invested another rupees, etc., etc., right. So, that is why this formula will work here. So, let us take this example, this business example to understand. This says Mr. Mohit deposits 1200 today in an account that pays an 8% interest annually. 2 years later, he deposits an additional 1400 into this account. How much will he have in his account 4 years from now? So, how many years in total? We have n of 4 years, but in the initial 2 years we do not have spent the whole money. We did not invested the whole money on the day one. On the day one we invested 1200 rupees, that remained there for 2 years. After 2 years I deposited another 1400 rupees, this Mr. Mohit here. Now, just equate this situation with provident funds. So, in public provident fund in India, we have a very good example. What can we do in public provident fund in India? We can deposit, of course, there is a minimum requirement of 500 rupees. We can earn interest up to 1,50,000. We cannot earn interest more than that in that year. But nevertheless, I have a freedom to deposit anything between 500 to 1,50,000. So, you would have surplus of 1 lakh rupees, I may have 70,000, another person may have 60,000 and so on, right. And the life of the provident fund is 15 years, the one account which is opened. So, in that 15 years, I may be submitting or depositing different amounts every year basis on the money available to me. This is what is uneven cash flow. This is a real example every day we come across. So, how would we solve this Mohit situation? So, here what is happening, we are 1200, we will multiply it with compound value interest factor for I, how much is the I here? 8%, and n would be 4, because first 1200 is deposited on the day one, it will give me interest for 4 years, right. But the another 1400 which I deposited 2 years from now, they will give me interest only for 2 years, right, because first 2 years those 1400 were not there. So, then compound value interest factor for I, this 8% and year would be n would be 2. So, if I go to table and get the factor for the first one, that is for 4 years at 8%, my factor is 1.3605, and that is why 12,000 is multiplied to 1.365, and in the second situation my factor is 1.1664. So, my 1400 would be multiplied by 1.664, because here the factor is for 2 years. So, I get the answer by multiplying 1200 into 1.365, my total would be 1632.58 paisa, and multiplying 1400 with 1.1664, my value would be 1632.96. The total of these two, the compound value of 1200 and 1400 respectively combined together for same rate of interest but different n, would be total of 3265 rupees 54 paisa. So, I hope you were able to understand this very well. So, we will move and we will talk about the fourth situation when we talk about compounding of annuity. So, let me explain you first before we go to any example that what is an annuity. The term annuity is very commonly used, we all know the situation. Annuity is basically a series of equal payments, which we make at a fixed interval for a specified number of periods. So, there are three things important. My amount which I pay or receive for annuity, that amount is equal. My interval, the time interval between the payments is equal, or between the receipts is equal, and n is known to me. We know the specified period, right? If n is not known to me, it becomes perpetuity. Okay, so take example, we take loan for house, for car, for anything. So if I have taken house loan, home loan, what I am paying? I am paying monthly installment. Same could be with you, for your car, for your scooter, for your house, you may have taken loan. So we are paying equal amount, let's say 10,000 per month. Per month means after every 30 days I am paying, and I am paying the same amount, 10,000. So amount is equal, interval is equal, and my house loan installments are told to me on the day when my loan is approved, that your n is 10 years, 12 years, 15 years, basis on your age, basis on your requirement, basis on bank's policy, everything. So this is mutually decided at the initial time, this is bargained, this is negotiated, right? And that is what. So my n is known, that I know my obligation to pay 10,000 per month is for 12 years, for 20 years, right? The more young you are, at the time of loan, your payment period would be higher, or your requirement. If you don't, that after 5 years you don't need money, you would have enough money beginning from tomorrow, next month, and you will be able to pay a good installment, your n could be less. But nevertheless, annuity means these three conditions: equal amount, fixed in time interval, and n is known. So how to compound an annuity situation? That if I am depositing, recurring deposit, for example, in Indian banks, where we deposit the same amount every month, 5,000 every month, 10,000 every month, and there are so many more investment options where we are paying monthly money. So how much would it turn after few years, after n period? So here future value of annuity, we put future value A capital is annuity, n is the given period, is equal to PMT or AMT. In case you use Excel, there or softwares, PMT or AMT word is, so AMT, PMT. PMT is the payment every month or every year, the amount of payment, and AMT is amount, the one and the same thing. That's why it's oblique, multiplied by future value interest factor for annuity for given I and given n. So FVIFA small I small n. I stands for rate of interest, n stands for year of compounding. So future value interest factor of annuity comes from the table, the annuity table. So we have two types of compounding table: compounding of 1 rupee, so that is 1 rupee or $1 compounded annually of XYZ rate, or we have another table which is compounding of an annuity investment made at the end of the year. So that is where we get this factor from. We can solve it otherwise, by using the simple calculator as well, but this is factor which is available in the table, and it makes things easy. This function, this compounding discounting function is available in Excel as well. If you go to analyze, there are compounding discounting available options are there. So let us take few examples where compounding of future interest. What is compounding factor? I have used this future value interest factor in the previous slide. So this is basically nothing. It refers to the multiplier which we use to calculate the future compound value of an annuity. So that factor which was future value interest factor of annuity for given I n, which I showed you, or which the table shows, is nothing but the multiplier which is used to calculate the future compound value of annuity. So let us take this example here in a small caselet. In fact, the company XYZ is establishing a fund to retire rupees 5 lakhs 8% debentures. So this is a good application even of the compounding. So a fund to retire 5 lakhs 8% debentures 10 years from today. The company plans to put a fixed amount into fund each year for 10 years. The first payment would be made at the end of the current year. So, it is an ordinary annuity or due entry. So, there are two types of annuities. So, I am not getting into that, just to go with the example. The company anticipates that the funds will earn 6% a year. What equal annual contribution must be made to accumulate 5 lakhs 10 years from now? So, here this is a good example that I borrowed money, I have to pay it back. I am paying 8% interest annually, that is fine, that is not considered here, but I need to accumulate 5 years from today. How much should I pay in the bank? The bank is paying me 6%. So, do not get confused, there are two rates of interest. One 8% in the second line itself, that is what the company is paying on debentures to debenture holders. So, do not get confused. My interest which I would be earning by on the deposits I accumulate in the bank is 6%. So, here rate of interest which is important is 6%, and how much what is the value of n is 10 years, because you are going to accumulate for 10 years. So, the question is that how much money should I accumulate every year, or I should deposit every year in the bank. So, it becomes 5 lakhs 10 years from now. This is the question. So, the future value of annuity is actually equal to, as we just discussed, the PMT multiplied by future value interest factor for an annuity. For given I is 6 and N is 10%. So, here 5 lakh is actually the amount which so PMT is known, the present value 5 lakh divided by the factor comes from the table. 13.181 is a factor given in the table for N10 for I6, right. So, if we divide 5 lakhs which we want to calculate, my future value is 5 lakhs. So, if I divide 5 lakhs by this factor, I will get the amount, the PMT, the value of PMT. So, what is missing in the formula is PMT, right. So, equation is same, we have kept the future value factor annuity 5 lakhs equal to PMT multiplied by the factor comes from the table 13.18. So, if I divide future value 5 lakhs, that is the desired value to accumulate, with the factor, I get the answer 37,933. So, it means this company XYZ Limited needs to deposit 37,933 every year to accumulate total of 5 lakhs from now, right. So, this is how it is. So, I will take one more example before we conclude. So, here the example is the compounding of an annuity. You are investing in a bank account which has a nominal annual interest rate of 9% compounded annually. So, if you invest in rupees, if you invest rupees 6,500 today, how many years will it take for you to account for to grow rupees 10,000. So, आपको कितना करना है? You want 10,000 rupees, but you want to invest 6,500. What is not known is that how many years will it take. So, here we know the future value 10,000 is equal to present value PMT is 6,500 multiplied by the factor for N and interest rate 9, I and N, I is 9, N is missing. So, if I go to the table, I will find, if I divide 10,000 with 6,500, I get 1.538, this factor. And if I go to table, I will and refer to table, you will see close to this value is 1.539 at N 5. So, we just go and look at the table and we get the answer. So, at 5 years, and at I9, my answer is, equal to 1.39. The factor is 1.539. So, that is what I got by dividing 10,000 with 6,500. Right. So, we can find N, we can find I, we can find PMT. So, we can go on for long. So, the last situation, the fifth situation is how do you compound and perpetuity. Perpetuity is a situation where perpetuity is where N is not known, right. So, that is the fifth situation. we will take this situation in discounting factors when we do the discounting situation in future lectures. So, but perpetuity principally is a situation where n is not known, otherwise it is very much like annuity. The amount is same, I is known to you, but n is missing. So, in that case the compounding can be done. So, you just keep on depositing every year, so you will not stop, that is not known to you. So, the first four are more important in compounding, perpetuity is still important in discounting. So, this was the application of compounding in various business situations, and I hope I was able to help you understand the time value money, only one aspect of it, compounding, and discounting will be taken in future lectures. So, looking forward to see you soon in future. Thank you very much friends. This is time to sign off. Thank you.